Welcome to the USACE Sea Level Change Calculator tutorial. I'll demonstrate some of the functionality and go over the output tables and graphs. Let's begin by going over the User Input and Options section. The highlighted area contains several options and input boxes to customize the calculator's output. You'll want to select the appropriate gauge from the combo box, or you can click on the map to find the closest gauge to your project area. I'll show you how that map works in a little bit. Let's select the gauge in San Diego. Click on the gauge pull down to see a list of available gauges. The gauges are listed in NOAA ID order, and they generally go around the coast from Maine to Alaska in a clockwise direction. Scroll down to the appropriate gauge and click on it. This will prompt the calculator to develop the projected curve tables and charts based on the selected gauge. The gauge map to the right will zoom to the selected gauge. Scroll down the page a bit to see the calculated curve table and chart. The table and chart shown here are based on the default settings, showing the USACE curves with a project start year of 1992, plotting every 5 years to the year 2100, with all values expressed in feet relative to NAVD88. For the selected gauge, you can also see that the average water surface, or mean sea level, is a little over 2.5 feet above NAVD88. Scroll down a bit farther to see the table and chart showing the tidal datums and extreme water level probabilities for the selected gauge. Again, the table and chart will be relative to the user's selected options. In this case, we're still seeing the defaults. All of the datum shown are relative to NAVD88 and are expressed in feet. The chart makes it easy to visualize the relationships between the datums and the extreme water level values. I've scrolled back up to the options section to customize the calculator's output. Let's enter in a FEMA baseflow elevation of 5.3 feet relative to NAVD88 for the area. And I'd also like to see the NOAA curves plotted alongside the USACE curves. And I'll go ahead and select the NRC 2013 option to show their projections along the west coast. You can click on the link to see the full report. Now let's scroll down to see the new results. You can now see both the USACE and NOAA curves, along with the projections from the NRC 2013 report. Also notice that the BFE is plotted at 5. Let's scroll up again and change the units to meters, plot some extreme water levels, and change the project's lifespan parameter. So select the meters option. So let's also select the 100-year extreme water level from the pull down. Let's change the project start year. We'll enter in 2015. As soon as you have 4 digits in the project year, the calculator automatically recalculates everything. And we'll change the project end year to 2095. Scroll down to see the updated results. You can now see that we're in meters. We now start in 2015 and end in 2095. And the chart is now showing the 100-year extreme water level plotting on top of the USACE high rate curve. Now let's scroll back up to see the gauge. As I mentioned before, the map is from Google, and you can pan, zoom in, and zoom out. Now let's zoom out to show the region, and we will click on another area to see the calculator select the closest gauge. You can use the scroll wheel on your mouse to zoom in and zoom out. I'll click on the map near Encinitas, and the calculator will locate and zoom to the closest gauge and use the previously entered options and user inputs to calculate the curves for the selected gauge. So click on the map, and the map will zoom to the closest gauge. You can turn on the satellite view by clicking the satellite button in the upper right hand corner. Scroll back down to see the curves calculated for the selected gauge. We have seen the calculator's basic functions. If you would like more information, you can read the guidance documents, which are all available by clicking on the links above the calculator. I also suggest reading the user's manual for additional instructions.